Okay, hello, good afternoon, everyone. Welcome back to our December week 2. Right, so yeah, friendly reminder, next week will be December week 3 and 4. So you will be attending 2 classes next week. Okay, so make sure you refer to your schedule. Okay, it is advisable for you to go for week 3 then week 4. I mean, if you have no choice, then you can attend week 4 first, then week 3. But okay, the thing will be a bit blurry because okay lah, form 5 will still be okay lah because you'll be doing revision. Okay, so week 3 and week 4 next week. If you cannot attend, then please make sure you request for video because the following 2 weeks will be holiday. All right, so let's go into our revision. Okay, let's continue on our chapter 11. Okay, so last week we have finished all our calculations. Okay, the velocity and acceleration one. Okay, and we have done our ticker tape and graph. All right, so what are we doing today? We are continuing on our gravitational acceleration free fall. And of course, I'm going to finish inertia as well. Okay, so today's stuff will be, a bit easier. Okay, there's not much calculation. Okay, basically it's more towards theory learning. Okay, so what is gravitational acceleration and free fall? Okay, as you know, we are on Earth. Okay, we experience this acceleration due to gravity. So the Earth's gravitational force is the Earth pulling force acting on all objects with mass. Okay, as long as you have mass, you experience gravity. Okay, so something as light as air, even they experience gravity. Okay, so this is why heavy air will drop to the bottom of the atmosphere, like carbon dioxide and oxygen. Okay, only the light air will be at the top. Okay, something to do with your density as well. Okay, so SI unit for gravitational force is Newton. Okay, he's the guy who found it out. So Newton. Okay, and you need to know G is at 9.8 or 10. This depends on the question. Okay, what is G? G is the acceleration due to gravity. That means if you jump down from a building or a plane or even a chair, you will experience this acceleration. Okay, sometimes they will ask for 10. If the question gives you 10, then you use 10. If the question gives you 9.8, then you use 9.8. Okay, it depends on the situation. So the unit is ms negative 2. Okay, why is it negative 2? Because it's acceleration. Remember, if it is ms minus 1, then it's velocity or speed. If it's minus 2, then it's acceleration. Okay, so this is the experiment. You can read this yourself. Okay, nothing really much to say here. So what is a free fall? Okay, jatuh bebas. A free fall is when an object is falling down due to gravity only. Okay, only. So only Earth's gravitational force acts on the body. There's only G acting here. Okay, that means free fall only happens in a vacuum. Why? Because you see, in a non-vacuum, you always have air resistance. This is why feather and stone, they drop at a different speed. Feather will just float around before they drop because they have very strong air resistance. Okay, and they are very lightweight, so the air resistance is very pronounced. But for stone, yes, they have air resistance as well, but since the stone is so heavy, the the air resistance doesn't really matter much, so they fall very quickly. Whereas in a vacuum, okay, both will drop at the same speed. They will reach the floor at the same time because both has no gravity, has no air resistance. Now this is what we call free fall. Okay, free fall. Okay, it's due to Earth's gravitational force only. Only gravitational force. Only gravitational force acts on them. There's no air resistance, no friction, none whatsoever. There's only one force acting on them. So that's a free fall. Okay, so two situation, free fall. This one you can read this yourself. Basically, nothing important. Okay, as for the graph, I'm not going to mention this because acceleration is a graph that you never learn. Okay, you might say, hey sir, why is the displacement time graph going curve one? I thought displacement time graph is always up. straight, up, down, or straight line, whatever. You don't learn curved lines, okay? So that's not your syllabus. I mean, if you want, you can recognize the shape because that's what they're going to ask in your objective question, okay, the ABC one. So why does it look like this? Because if you throw a ball up, okay, they are going to go to the maximum displacement, and as they fall back down, they will return to original point. This is what happens when you throw the ball and it comes down. Okay, and the velocity, it will start. Okay, you know what? I'm not going to skip this thing. Okay, it's not a concern. Okay, if you want, you can read this, but I'm not concerned with this because even if they ask for graph, it's going to be in velocity and acceleration there. It's not going to be in free fall. Okay, so moving on, let's go to our mass and inertia. This is the simplest thing. There's no calculation involved here. It's only pure theory. Okay, so mass, you know what is this? It's the quantity of matter. How many atoms you have inside you? That's your mass. Okay, how many atoms is in an object? That's the mass. And so anything that has mass, they will experience inertia. Okay, so what is inertia? Inertia is the tendency of an object to resist any change in its original state. Okay, or you can just say, don't need natural tendency of an object to resist its state of motion. Okay, sometimes I don't like all this definition. It's state of motion. Okay, whether at rest or this one no need cut. Okay, so I just like to remember it as tendency of an object to resist its state of motion. Or change in its state of motion, sorry. Any change. Okay, so or put it simply, things at rest stay at rest. Moving things stay moving. Okay, I know this is a kiddie way to put it. Okay, if I want to explain to a 5-year-old, okay, I will say inertia is things at rest stay at rest. Okay, what do I mean? Every object, as long as they have mass, when you try to change them, they will resist you. Okay, if a car is not moving, you try to move it, they will try not to move. They will give you a resistance. You want to move them, the car will say, no, I don't want to move. Okay, now so this is inertia. Things at rest stay at rest. Okay, and on the opposite, if a car is moving, you try to stop it. Let's say a car is rolling downhill, you try to stop it, the car will say, no, I don't want to stop. So moving things stay moving. Okay, so this is inertia. The higher the mass, the higher the inertia. The more heavy something is, the more they will resist you. Lorry is very hard to push and it's very hard to stop. Bicycle is very easy to push, it's very easy to stop. You see, easy, hard. So this is inertia. Okay, so it is not a physical quantity, it cannot be measured, it has no value or unit. Okay, so this is Newton's first law. Okay, but Newton's first law actually states inertia. Okay, so will remain in its original state. Okay, if no external force acts on it. Same thing lah. Okay, basically the same thing. Okay, so let's look at mass and inertia. As I said, the larger the mass, the larger the inertia. The heavier your car is, the harder it is to stop. Okay, so to stop an empty lorry, if you are driving a lorry without any load on you, it will be reasonably easy. But if you have fully packed, you have sand, you know those sand lorry, they are packed with sand. That one is very hard to stop because you have more mass. Okay, so the less, what is it, lesser? Okay, as you see, hit this stupid word there's no lesser. Okay, it's like saying there's importanter. Then is there lesser? No, it's less. Okay, so the less mass, the less inertia. Also, sorry I used to teach English I cannot stand words like this. Okay, so larger mass, larger inertia. Okay, you get what I mean. Okay, what is this inertia balance? Is not your concern. I'm just gonna cross it out. Okay, so a positive effect, where do you use it, Delian? Okay, the most important part of inertia is for you to memorize. Where do you use it? Okay, so number one, okay, let's look at the positive first. Okay, so the loose head of the hammer can be tightened by banging its handle against the hard surface. Okay, so okay, if you ask me this, I don't know about this. Okay, because I've never experienced a loose hammer head before. Okay, but if you do, if your hammer head is loose, so what do? You bang it on the table because when you move, when you move the handle, the head moves as well. But when you stop the handle suddenly, the head is very heavy, the head has very high inertia, the head want to keep moving. So it will be drive down, it will be, stuck down to the handle, and now the thing is tightened already. Okay, so what else? Drawing your umbrella. So you draw your umbrella by turning it. So when you turn the umbrella, the water droplets turn as well. And then suddenly you change direction, the water droplets will want to keep following its original direction, so they will fly off the umbrella. So inertia. Okay, so same goes to your sauce. When you move your bottle, the sauce moves as well. Follow the motion. And when you stop, the sauce don't. The stop doesn't want to stop, so the sauce will just come out of the bottle. Okay, so negative effect. You need long runway because the plane has very high inertia, very hard to take off, very hard to touch down. So that's why they need a long runway for them to gain the enough inertia or to kill off the inertia. All right, so same goes to this one. You have your airbag and your seat belt. These things are to, reduce inertia. And if you have a very heavy ship like this tanker, you need to shut off your engine 10 kilometers away because this thing will slow down. Okay, for it to slow down because it has high inertia. All right, so how do you reduce effect of inertia? This is mostly to do with car safety lah. That's why you need your seat belt, you need your airbag, and if you're transporting timber, you need a steel structure. If not, when you break the car, when you break the lorry, this thing will just keep moving and bang in front of you. Okay, that's how you die. And of course, your oil truck is separated into few compartments so that this is divide the mass so that this doesn't happen. Okay, if I'm having oil in my oil tanker, if this thing slosh around, it's gonna affect my braking. Okay, so you get what I mean. Some effects are not included here. Oh, like your bus one. When a bus stops, okay, you will lunge forward. When a bus starts accelerating, you will be thrown backward. So that is inertia as well. Okay, so let's go to exercise. Okay, so last week I think I stopped here. I'm gonna skip the motion question. If we have the time later, then maybe we can come back. Oh, there's a lot of motion question. Okay, anyway, let's go to question 21, page 17. Okay, I'll come back to that later. Let's finish what we need to finish today first. Hang on, let me check how many questions are there. Okay, there are 25 questions. Oh, okay, there's only 4 questions here. That's not a lot. Okay, so let's look at A, 21A. What is Earth's gravitational force? Okay, it is a force pulling on all objects due to Earth's gravity. Okay, so for BM, daya yang menarik, menarik semua objek disebabkan okay, Earth's gravity. You can say Earth's gravitational field also can. Okay, oleh gravity. Okay, sorry, this annoying shit is happening again. My screen is disconnecting. Give me a moment, guys. Oh my goodness. My freaking god, I'm paying for Zoom and this is the shit that happens every week. Getting real tired of this shit. Like seriously. Okay, a moment guys. Okay, here comes. Okay, this will happen like a few times if you're really unlucky. So anyway, B, what experience does an object have if it falls due to effect of gravitational force only? So what is that? What does it experience? This question is so deliberate. There's only one thing you learn about this. It's your free fall lah. Okay, it experiences free fall. Okay, here. Okay, so free fall doesn't exist. Okay, if free fall were to exist, then skydiving wouldn't work. Okay, you see skydiving, when you jump down from a plane, do you immediately come plunging down? No, you don't. Okay, there's air resistance pushing on you, so you can kind of glide around. Okay, I mean, if I were to throw you off a plane, you wouldn't die immediately. It will take you a while to reach the ground. Okay, because there's air resistance, especially if you wear a diving suit, okay, and you open yourself like that, you increase the air resistance. Okay, yes, you will still fall, but it will take a while. Okay, but if you are in a free fall, then this wouldn't happen. You jump down from a plane, immediately you start plunging down. Okay, but it doesn't happen lah. So you can say that free fall doesn't exist in this world unless it's a vacuum. I mean, theoretically, okay, technically speaking, you don't get free fall. Okay, because there's nowhere in this world that is vacuum unless you have a machine or something. That's a different story. Okay, so C, the non-free fall motion of an object is affected by external force. Okay, daya luaran. What is external force? External force are all the small force lah. Okay, like your friction is an external force, air resistance, or we call it drag. That is your external force, daya luaran. This thing will affect your motion. Okay, so D, a ball is dropped onto a concrete floor. The diagram shows the movement that was captured using a stroboscope. Okay, a stroboscope is basically a high-speed camera lah. Okay, so this is what happens. So based on your observation on the diagram, sketch a graph in the space above to show the velocity of the ball at time. Okay, I don't think they will ask this in exam, okay, as I said just now, but if you want to know, okay, here goes. Okay, very easy. When you start dropping the ball, okay, the velocity is 0. Okay, the velocity here is 0 because it just start falling. Okay, when you start skydiving, it is 0. And then as you go down, you go faster and faster and faster, faster and faster. And before you reach here, the moment you touch the ground, your velocity is a maximum. Okay, you have maximum. Assume that your parachute doesn't open. The moment before you land on the ground, you are at the highest speed. Okay, and then when you hit it, immediately you bounce back. Okay, immediately you bounce back at the higher speed also. And then as you go up and up and up and up, okay, when you reach here, you will reach back at speed 0. Okay, you reach back at speed 0. So what happens here? You see, velocity from 0 to max. Okay, so it goes like this. Okay, this is your velocity. Okay, ms -1. This is the time. Okay, as time goes on, the speed increase, and immediately when the speed bounce, okay, and it will come back to 0. So come back to 0. So you will see a graph like this. Okay, so in just now, you also see the same thing, but they split this thing they do the first part first. Okay, when the object is released, it increases uniformly, and then when it moves upwards, the velocity decreases like this. So it's like a triangle. Okay, because the speed increase. Okay, increase, bounce back, decrease. That's why when the ball reaches the top, it stops for a moment, it pauses for a moment. That moment is when the speed is 0, and then it goes again. Like that. Okay, that's what the graph looks like this. So by referring to a graph in 1A, describe the movement from A to B. Okay, from A to B, what is it doing? Do you still remember our velocity time graph? What does the gradient mean? Okay, the gradient means acceleration. Okay, so can you see this is a uniform acceleration? Okay, uniform acceleration. No, okay, you want to say increasing velocity also can. It's the same meaning. Say increasing velocity or uniform acceleration. They represent the same meaning. But I like to write uniform acceleration more because it sounds better. Okay, so next, number 22. The diagram below shows a graph of motion of a ball that has a free fall. Okay, that has free fall. Free fall is not a thing that experiences free fall. What the hell is this English? Okay, so as you can see, the displacement slowly it is going. Why is the graph looking so weird? Okay, it is going like that, increasing, and then suddenly it goes higher again. So as you can see, the gradient, okay, if you still remember, in displacement time graph, the gradient is the velocity. Okay, so as you can see, this velocity is low, this velocity is high. Okay, so what is the state of the ball at point O? Okay, at point O, it is zero velocity. Okay, kalau laju sifar. Okay, why is it zero velocity? Because at the top, like I said, when you first release something, when you skydive out of a plane, your velocity is zero at first, and then only you will slowly go faster. Okay, so calculate the velocity of the ball in the areas marked P and Q. Okay, so velocity is to calculate this gradient here. So to calculate this gradient, it is y divided by x. So this is 2, right? Yeah, 2 divided by 4. Okay, 0.5. And speed here is 0.5. And then for Q, I need to use y divided by x again. So from 7 to 4, 3, from 8 to 6, 6 to 8, this is 2. So y divided by x, 3 divided by 2, this is 1.5. So as you can see, the speed here is slower, this is faster here because the gradient is steeper. So for P is 0.5, Q is 1.5. Okay, this is rather easy. So based on your answer in B, state the area with small gradient. The area, why would you want the area? This is a very weird question. Okay, I get what they are trying to express. Okay, displacement of a free fall, it goes like this because the displacement just keeps going faster exponentially. It goes faster. Okay, I'm not gonna explain why. Okay, you don't see a curve graph in your syllabus because that's like quadratic already. Okay, quadratic is in maths, that is not in your syllabus. Okay, I'm not gonna dive too deep into that. Okay, so the area, the small gradient, they want the area. In displacement diagram, we don't count the area. Okay, you know what? Let's skip this question. Okay, so the time interval of the ball with high velocity. So high velocity is from here to here. Okay, from 6 seconds to 9 seconds, 3 seconds. Okay, so what conclusion can be made from the graph? Displacement increase. Okay, so displacement it increase as time increase during free fall. Okay, sasaran meningkat dengan peningkatan masa ketika jatuh bebas. Okay, during free fall it goes faster and faster. The displacement increases. Excuse me. All right, so as you can see, they will very suddenly touch on the graph for gravity because it's not really your thing. They can ask certain things, but they cannot ask certain things. So it's like a halfway. So as well, they will not touch this thing. Okay, so anyway, question 33. Okay, so diagram below shows two similar tins hung from horizontal wooden rod. Okay, so one tin is filled with sand, the other is empty. So as you can see, the right hand side one should have higher inertia. Okay, and then the left one should have lower inertia because it's empty. Okay, so the left one, the empty one, easy to push, easy to stop. The left one, the full one, hard to push, hard to stop. Now that's inertia. Okay, so A, if both tins are pushed with the same force, which tin will continue to swing for a longer time? Of course, it's going to be the tin filled with sand. Okay, tin berisi pasir. Okay, explain your answer. Okay, it has higher mass. Okay, and higher inertia. Here mempunyai sistem lebih tinggi, inertia lebih tinggi. For BM is SIA. Okay, remember to compare the mass. Compare the mass. Higher mass, higher inertia. Right, because inertia, the only factor is mass. So B, how can the two swinging tins be stopped at the same time? How can it be stopped at the same time? You can either empty this thing, or you can fill this thing with sand, I guess. I'm not sure whether what I can do or what I can't do is stop at the same time. Okay, let's just say fill the empty tin with sand. Okay, isi tin kosong dengan pasir. Why? Because it was the same as same inertia. Isim sama, inertia sama. Okay, or empty the tin filled with sand. Kosongkan tin berisi pasir. Same thing, same mass, same inertia. Just make them same mass. Okay, there's no way for you to reduce inertia without sorry. There's no way for you to change the inertia without changing the mass. Okay, so C are the observation of the experiment due to gravitational force. Explain your answer. You know, this is a very weird question because you don't ask it like this in exam. What? What? Because this feels weird to do, even as someone who who study physics. This is it due to gravitational force? Uh, yes, I would say. You know what? Let's skip this question. This is inertia is inertia, gravity is gravity. They are not going to mix these two together. Okay, D. Why does an oil tanker find it more difficult to change direction compared to a boat if both are traveling at the same velocity? Okay, so same thing, inertia. Okay, oil tanker is heavier. Oh, okay. Oh, lori taki minyak. Lori taki minyak lebih berat daripada weight. Don't say heavier lah, because this is a very risky word. I would say higher mass, sorry. Okay, as higher mass. You have to use the word mass because heavier could be weight or could be mass. Okay, mempunyai jisim lebih tinggi. Okay, so we have to use the word mass. Try to use word like heavier because heavier is not a scientific word. Compared to mass. Okay, so oil tanker has higher inertia than a boat lah. Finish the sentence yourself. Lori tangki minyak mempunyai inertia yang lebih tinggi daripada kapal. Okay, so next 24. Moving on. So diagram shows the condition of passenger in the moving bus. So state the observation when the bus stops suddenly. Okay, so when it stops, okay, they will be thrown forward. Okay, passengers will be thrown forward. Okay, dibuang harapan. Okay, because when the bus was moving, you are moving with the bus. When the bus stops suddenly, you want to keep moving. Okay? Moving things stay moving. That's why you lunge forward. So when the bus stops, you stop. But when the bus goes forward, you want to stay backward. You want to be stationary. So you lunge backward. Okay, so that's inertia. So explain the observation in A. Okay, so wow, this is 2 marks. How can I? Okay, this should be very long explanation. Okay, I'm going to keep it short. When bus, okay, when bus stops, okay, passenger has inertia, passengers inertia. Okay, so what happens? Passengers want to keep moving forward. Okay, after either bus berhenti, inertia. Okay, hendak atau bergerak. Okay, there's a tendency for the passenger to keep moving. Okay, that's an inertia. Okay, so C, a bus full of passengers is difficult to stop compared to an empty bus related with inertia. Okay, so the mass of bus full with passenger is higher than empty bus. I'm not gonna write the full answer lah. It's gonna be very long. Why is this only one line? Goodness me. Okay, Jisim bus penuh dengan penumpang mempunyai wait. Bus penuh dengan penumpang mempunyai jisim lebih tinggi daripada bus kosong. Wow, what a long answer. Okay, so full bus has higher, say inertia is higher. Blah blah blah. Finish it yourself. Okay, a bus full with passenger has higher inertia than an empty bus. Ooh, only 2 marks here. Okay, I'm not gonna overdo. You know this yourself. You get what I mean. Okay, I'm not gonna just write back the same thing. So D, give one example of inertia in daily life. You can say shaking, okay, pouring sauce out of a container. Okay, wrong sauce. Okay, you can say drying an umbrella, or you can even say animals drying themselves. And when dogs or cats they dry themselves, they do it the same as the umbrella. They will just shake left to right. Things. The pouring sauce one. Okay, you know what? Okay, there's so many. So 25. Figure 6 show two spheres the same size, both make to swing at the same time with the same force. So it's the same question. So iron sphere is heavier, obviously. The wooden sphere is lighter. So which sphere will stop swinging first? Explain your answer. Of course, the wooden one. Okay, because it has lower inertia than iron sphere. Okay, inertia lebih rendah daripada sfera besi. Right, so B, from the result, what inference can you make regarding the relationship between mass and inertia? Okay, what inference can you make? Inference means explain. Okay, what inference can I make? You can talk about the mass. I think you just talk about the inference already because just now I explained, right? Because it has lower inertia, right? The lower inertia is actually the inference already. But oh, they want mass and inertia. Okay, so we can say object with higher mass has higher inertia. Okay, object dengan jisim lebih tinggi dari inertia lebih tinggi. Okay, higher mass, higher inertia. Okay, so C, give an operational definition of inertia. Okay, so again, this question you will see a lot. As I said, what is operational definition? It is a definition based on what you see. So what is it? Inertia is how long does it take for the ball to stop? Because they want it to stop swinging, right? This experiment is about stop swinging, right? So it's about how long it takes for the sphere to stop swinging. Okay, so inertia is now what is inertia? Inertia is a property. You have to first say what is it? Is it a thing? Is it a, a measurement? Okay, is it an object? Okay, so inertia is a property. Okay, it's a property that is determined by how long it takes for a sphere to stop swinging. Sphere. Okay, inertia adalah ciri kan oleh berapa lamakah dia berayun atau berhenti berayun. Okay, how long does it take to stop swinging? Well, it's a bit long. Operational definition. All right, so this will only come out in section A. Oh, speaking of section A, we shall go back to section A later. Okay, last week we did skip through section A question. So this will come out in section A. So section A has 4 questions. Even if they ask, it's gonna be 2 questions at most. This operational definition. So even if you cannot answer, it's not the end of the world. Don't worry. Okay, you just write your definition based on what you see. Okay, you have to put your observation inside definition. Okay, that's the best way I can put it. So D, if a fast-moving car is suddenly stopped, what happens to the passenger? Explain why. Write it yourself. It's the same. Okay, passenger will be thrown forward. Okay, because passenger has mass, has inertia. Easy, easy. So next, oil tanker. The tank in the lorry should be divided into smaller tanks or not divided. Okay, okay, should be divided. Okay, harus diasingkan. Okay, come on, guys. All right, so based on the principle, explain your answer. Okay, so the carrying fuel. Okay, so the petrol is divided into compartments of smaller mass. Okay, petrol diasingkan kepada bahagian-bahagian yang berjisim lebih kecil. Okay, so petrol has smaller inertia. Okay, inertia lebih kecil. Okay, so smaller inertia, that means they easy to stop lor. The truck doesn't have to handle, you know, the extra inertia which affects the braking. So this is why if you ever wonder why a lorry has a weight limit, whenever you look at those lorry, they will put a black color label there. Okay, berat muatan. Okay, they will say maybe the truck itself is 2,000 kg. The maximum weight it can be is 2,005. If you don't obey, if the police checks, if you over carry something, they're gonna fine you, because this is how accidents happen. You see, Malaysia, when it comes to all these truck regulation, we suck at it. Okay, you see, truck, they are not supposed to come out in peak hours. Sometimes 8 in the morning, you will see a bloody truck on the road. It's blocking the road. Okay, and then number two, they have to, what is the most often overlooked stuff in a truck is the tire. Okay, it's the tire. This is why if you are traveling on a highway, sometimes you see black pieces of tire on the road. They will drive until the thing. Okay, when do you change your tire? You change your tire when the thing has no more tread on it. But truck drivers, they don't care. Okay, because the company, they try to save money, they don't change. They will drive until the thing bursts. Okay, so if you are driving halfway, there's a lorry beside you, there's a truck beside you. If the tire happen to burst right beside you, best case scenario, you will only be shocked. Worst case scenario, you will die. Okay, not even joking. So trust me when I say that a lot of Malaysia lorries they just overload on their maximum weight because they don't care. Okay, because all these big companies try to save money, they will put as much stuff as they can on it. Okay, so it's a very dangerous thing to do because you are changing the inertia. You are overloading the inertia. So coupled with a very poor maintained truck, if the brake doesn't work very well, then you have a very nasty accident. Okay, so next F, why a very long runway is required for the airplane landing. Okay, as I said, airplane has very high mass. Okay, there's high inertia. Okay, takes long runway to stop the plane. Okay, mengambil landasan yang panjang untuk menghentikan kapal terbang. Okay, jisim tinggi, inertia tinggi. The answer just keeps repeating. Okay, because as I said, inertia, there's nothing more to us. There's nothing to us. It is what it is. All right, so I believe that's it for inertia. Okay, let's go back to our page 1 now, shall we? Okay, now I'm jumping around, but last week I think we stopped. I think we skipped this, which is the section A1, and I almost forgot. So let's go to page 2, section A. You pray hard this SPM, they come out a lot with questions like this now. It's really easy. So number 1, diagram below shows the experiment to set up to study the relationship between mass and inertia. 5 coins of 50 cents are placed in a can. The mass for each coin is 10. Okay, so that's 5 coins at 50 grams here. So the can is pushed and the stopwatch is started. Oscillation is recorded and then repeated. So 5 points, 50 grand. Okay, 5 seconds in 20 seconds. Or 5 oscillation in 20 seconds. That means one oscillation is to come back and forth. Okay, so back and forth 5 times in 20 seconds. And then as you can see, it will oscillate more as the mass increase. Okay, this is the inertia. So 15 and then 20. Okay, so draw a graph of number. So this so 5, 10, 15, 20, 5. Easy straight line graph. So based on the answer, state the number of oscillation when it's 20. Predict if 500 is used. Okay, if I use 500, that's like double of this. Okay, it should be double too. It should be 50 oscillation. Okay, state one constant variable. What you don't change here? So many things. You cannot change the length of the string. You cannot change the mass of the bucket. Is it a bucket? A can. Okay, so you can say the mass of can. Jisim tin. You can say length of the rope. Okay, panjang tali. Okay, CV you should have plenty lah. In every experiment, there's only one MV. You're trying to change one thing. There's only one RV. You only try to observe one thing. The rest, they stay the same. Everything. All right, so you can even say the time. Okay, everything they do in 20 seconds. Okay, you can even say the mass of each coin. Every coin has to be the same mass. So many. All right, so number 2, diagram below shows an experiment to study the relationship between mass and inertia. So you have your metal block, you have your string. So again, why is it the same question? Okay, so this is 20. Okay, you know what? Why is it the same question? Goodness me. Okay, anyway, sorry for jumping again. Let's go to, okay, last week we did displacement time graph, huh? Okay, so today let's try to do some velocity time graph. Okay, let's go to question 15, velocity time graph. Because last week we did displacement time graph, we did the easy one. Okay, so if you still remember velocity time graph, the gradient is the acceleration. Okay, and the area under the graph is displacement. Okay, remember gradient is to go one step down, like displacement time graph, gradient go one step down is velocity. Velocity time graph, gradient go one step down, acceleration. Area is to go back up. So velocity time graph, area is displacement. But displacement doesn't go up some more because there's nothing there. So in displacement time graph, we don't consider the area because it means nothing. So find the displacement from A to C. A to C, how do you find displacement? You find the area. So how do you find the area of A to C? You calculate this part. Okay, this is a very weird shape. So what do we do? You can calculate this part. What I can see is this part plus this part plus this part. This is a trapezius. Okay, trapezium. So this part, let's look at this area first. So this is 1/2 times 10 times 5. Okay, because 1/2 x, y. X is 10, y is also y is 10, x is 5. Okay, so we get 25 here. Okay, this is 25. And then for this part, this is 5 here, 10 here. So 5 times 10, 50. For this one, it's 1 over 2. What's the opposite length? This is 5 plus 10, so 15. And then the height is 4. So I get 30. So sum of everything, I should get 105 meter. This area here is 105. Okay, remember I said your velocity time graph. The first part, positive gradient, positive acceleration. That means the car moves forward faster. It goes woo like that, okay, faster. And then A to B here, zero gradient, zero acceleration. Zero acceleration doesn't mean it's not moving. Zero acceleration means it's steadying the speed. Like I said, if you drive on a highway, drive 80 steadily, you have zero acceleration, but you're still moving forward. Okay, and then as you brake, okay, this part is when it brakes. When you brake your car, okay, when you step on the brake, it goes slower, but it's still moving forward. Okay, so forward, forward, forward. That's why the displacement adds up. So find the acceleration from C to D. Now C to D, acceleration is the gradient. So they want the gradient for this. So let me split it here. So your Y is 5 to 15, that means 13 here, and this is 4 here. So 13 divided by 4. So 13 divided by 4 is 3.25. That's minus 2. 2, okay, 2, because we are calculating the acceleration. Oh, this is a bit easy because there's only 2 questions here. Okay, so let's look at 16. Diagram below shows the velocity time graph by the motion of a motorcycle. So as you can see, velocity time graph. Okay, so the motorcycle moves forward faster, moves forward steadily, moves forward slower. Okay, braking the motorcycle. So determine the velocity when time is 3 seconds. When time is 3 seconds, the velocity is 12. There's no calculation needed here. It's too much. I don't think this is too much because it's just coming from the graph. So when time is 7 seconds, the velocity is 6. Wow, 2 marks again. No calculation needed whatsoever. So B, find the displacement in the time interval between 0 to 5. 0 to 5. I want this here. Okay, so I can use my trapezium method again. Here to here is 2. Here to here is 5. So 1 over 2, 2 plus 5. That's height. That's the height. The height is 12. Okay, so 3.5 times divided by 2 times 12. I get 21. Okay, 21 meter. If you're uncomfortable with this, you can just split it lah. Do it in 2 ways lah. This is the triangle, and then you do a rectangle. You add it together. Okay, so let's go to C. So determine the acceleration of the motorcycle from 5th to 9th second. So 5th to 9, acceleration is the gradient. So this is negative 12 over 4. Okay, why is it negative 12? Because it's going down. Okay, 0 minus 12. 12. The answer is negative 3. Okay, negative 2, acceleration. So please be careful. Okay, so I think I'm gonna stop here because the questions are, kind of repetitive. It's not many remaining actually. Okay, you can go and do this yourself. Answer will be posted in Google Classroom. Okay, so if your respective tutor did not upload, please let them know. Okay, because sometimes even I forget to check your answer by this weekend. Okay, so remind you again, next week, please come for 2 classes, or you can just come for 1 request for video, it's fine. Okay, so next week will be our last week already. All right, so I will see you again next week. Okay, that's it for today. Okay, I will see you again. Okay, so take care. Bye-bye.